Alright, today we're going to be talking about polynomials. The homework exercises on page 231, 16 through 52 all, and 56 and 57. So first, let's just review what a monomial is. Remember yesterday, a monomial is a variable, a number, or the product of a variable and a number. So a number, a variable, or the product of a number or variable. A binomial, bi means two. A binomial is two monomials that are either added together or subtracted. So x plus 5, or 2x minus 3, or x squared plus 2. Those are all examples of binomials. A trinomial has three terms. So x squared minus 2x plus 3 is an example of a trinomial. Everything bigger than that is considered to be a polynomial. So here I have x to the fourth minus 2x cubed plus 4x squared plus 3x plus 1. When we talk about the degree of a polynomial, the degree is the degree of the monomial with the greatest degree. So let's talk about that. Alright, so the degree of this monomial is 2, the degree of this monomial is 1, and this is 0. So the degree of this polynomial is 2. The degree of this is 2. The degree of that is 3. So the degree is the largest one, which is 3. So what would be the degree of the last one? It would be 8. So it is a degree 8. Because the degree of the monomial is the sum of these two. So it is 8, and the degree of this is 4, so the greatest would be 8. Next, I want to talk about like terms. Terms are alike if they differ only by their sign. Only by their coefficient. So terms are alike if they differ only by their coefficient. What is a coefficient? Say that louder, Sarah.
The number attached to the variable.
Okay, it's the number in front of the variable. So in this case, I have 5x. 5 is the coefficient. X is the base. And then I have negative 6x squared. Negative 6 is the coefficient. X squared is the base or the variable. All right, so up here, we want to talk about which ones are alike. They are alike if they differ only by their coefficient. Their variables are the same. So we have that 5x is like 12x, is like negative 6x. So these are all alike. Then we have negative 6x squared and 4x. Those are alike. And then we didn't have anything to go with 2x cubed up here, but we said we would make one up. So 2x cubed and 6x cubed are alike because they differ only by their coefficients. Their variables are exactly alike. So when we talk about addition and subtraction of polynomials, we want to make sure our polynomial is in descending order based on the degree. Descending order means from the largest to the smallest. It could be written in ascending order, but in general they write them in descending order. Then you want to distribute if you have to. You want to combine your like terms. Remember when you're adding and subtracting polynomials that you're just adding and subtracting the coefficients. You're not doing anything with the variables. So up here, I have a polynomial, two polynomials that we want to add together. You should really put them in descending order to begin with. So you'll notice the first polynomial is not in descending order. So how are we going to put it in descending order? Alright, so we'll change the order of it, and we get 13x cubed minus 29x squared plus 18. The second polynomial is in the correct order. So we have it in the correct order. We want to add these together. I like to add them up vertically. You can do it horizontally if you want. I think vertically is easy. Notice these are both x cubed. They differ only by their coefficient. These are x squared, but down here, we don't have quite the right number, do we? So what I would do is I would change this up. Put that up there. Okay. I would change this up so that I had a 0x to line up with my 7x. So then we want to add these together. And like I said, we're only adding the coefficients. So we get 38x cubed minus 47x squared plus 7x plus 6. How are y'all doing? Good? All right. Uh-huh.
What is something not a polynomial?
All right, so let's go on to, that is a good question. All right, so up here I have negative 2x plus 3x squared minus x squared plus 4x minus 2. All right, so we have 3x squared minus 2x plus 3. Y'all like to do this horizontally, so if we do this one horizontally, I would distribute my negative sign to get negative x squared minus 4x minus a minus makes it plus 2. So if you're going to do it horizontally and it is about subtraction, I would go ahead and distribute the sign. So I have 3x squared minus x squared for 2x squared. Then minus 2x minus 4x is minus 6x, and plus 3 plus 2 is equal to 5. Once again, if you do this vertically, you have x squared minus 2x plus 3. You have x squared plus 4x minus 2. You have to remember you're subtracting each and every one of those monomials. So you get 2x squared minus 6x minus a minus makes it plus 5. Okay, everybody okay with that one? So next I want to talk about multiplying monomials times polynomials. You need to remember two things. You need to remember to distribute, and you need to remember the rule x to the m times x to the n. You're going to add your exponents. So the first example I have up here says 3x squared times x cubed plus 4x minus 2. going to distribute this to each one of these. So we get 3x to the 5th plus 12x to the 3rd minus 6x squared. The same applies here. So negative 2 times 6 is negative 12x cubed. Minus minus makes it plus 8x squared. And then minus 6x. That's an x. Okay. Everybody okay with that? Next we have a binomial times a binomial. Bi means 2. Y'all like to use the word FOIL? Not my favorite word. I think FOIL goes with turkey for Thanksgiving, or it is what you fence with. Alright, so here we go. The reason I don't like the word FOIL is because when you get 3 terms, you have a middle, and what are you going to do with it? So here we go. We're multiplying x times x to get x squared, and multiplying x times 2 to get plus 2x. Then we're going to multiply 1 times x to get x, and 1 times 2 to get plus 2. You can string it out if you want. So I get x squared plus 3x plus 2. You want me to do another one?
Yeah.
Here's another one. Let's do these two. Alright, so we have 2x times 3x is 6x squared, and 2x times minus 1 is minus 2x. Then we're multiplying 1 times 3x to get 3x, and 1 times negative 1 to get minus 1. So we get 6x squared plus x minus 1. So on the next one, this particular one is a binomial times a trinomial. A binomial times a trinomial. And this is the reason I don't particularly like the word FOIL. But it's an okay word. Because this one doesn't have a first, outer, inner, last. It has a first, outer, inner, middle, and last. But so we're going to multiply the first number 3x times each one of these. So we get 3 times 3 is 9x cubed. 3x times 2x is plus 6x squared. And 3x times 2 is minus 6x. So then we're multiplying these together. So we get minus 3x squared minus 2x minus a minus makes it plus 2. So we get 9x cubed plus 3x squared minus 8x plus 2. Everybody okay with that? Want me to do this one again?
Wait, hold on. Never mind.
We're just distributing.
I forgot to put the square sign on it, and that messed up the whole problem. It's just distribution. I got it.
Right. And the rules for exponents, x to the m times x to the n. All right, so on to special cases. I'm trying to figure out how to write this so it's easy to explain.
is it? Or what if it's a trinomial times polynomial?
You do the same thing. So up here, we have a plus b squared. You need to write it down twice. It means a plus b times a plus b. You can FOIL it. When you FOIL it, you get a squared plus ab plus ab plus b squared. You get a squared plus 2ab plus b squared. But like the title says, it is a special case. This is always the first term squared. Which is this one. The second term multiply these together. And double. And the last term is the last term squared. So let's talk about it again. So square the first term, a squared. Multiply these together, a squared ab, double it, and square the last term. Or you can just FOIL it. The same applies here, except for the fact that this is a minus b times a minus b is the same thing as a minus b squared. You should write it down twice. When you multiply this together, you get a squared minus ab, then minus ab plus b squared. So you squared the first term, you've multiplied these together and doubled it, and you square the last term. So the next is one you've got to know how to do. It saves time, and it's an important concept for things we do later on. You'll notice that these are almost alike. A plus b, but this one's a minus b. They are called conjugates because they differ by their sign. Their sign, in this case, being this sign and that sign. When you multiply them together, you always get the difference of two squares. It will be a squared minus b squared. Now you can FOIL it. It takes longer, and you should learn that. But if you multiply them together, you get a squared minus ab and plus ab minus b squared. And you see where these two in the middle cancel, and you get the same thing. It's easier if you just learn that a plus b times a minus b gives you the difference of two squares. So up here, I just have a few more examples. I'll let y'all work these real quick. so like I said, you want to write this down twice. You can FOIL it together, but it's going to be the first number squared, so that's 9x squared. Multiply these two together and you get 15x and double it, so you get 30x. Multiply the last two together and you get, or square them and you get 25. So once again, you can multiply it out, but that's what you're going to get. Here, square the first term, so you get 4x squared. Multiply these two together and you get -6. Double it, you get -12x. And square the last term, so you get +9. That takes me to a problem that looks like this, and I told the other class that I will probably take off double on a test. So if the problem's worth 5 points, I'll take off 10 if you miss it. So what does that mean, x minus 5 cubed? That means for you to write it down 3 times. X minus 5 times x minus 5 times x minus 5. If I gave you 3 times 4 times 6, what would you multiply together first? 3 and 4? Well, some people might multiply 4 and 6. It doesn't matter. All right, good. So I'm going to multiply these together. And when I do, I'm going to get x squared minus 10x plus 25. Then I have to multiply by x minus 5. So we'll multiply this times each one of these. We get x cubed minus 10x squared plus 25x. Then we have to multiply these together. We get -5x squared minus a minus is plus 50x minus 125. We add these together and we get x cubed plus 15x squared plus 75x minus 125. That is not the same as this. They're not the same. They don't mean the same. Okay, this does not equal that. All right, so call it a day. We can figure out how to stop it. I don't know.